Imagine this. You're falling into a black hole, your body stretched, your fate sealed. But instead of dying, reality fractures. Suddenly, you're both alive and dead, drifting through space in a quantum paradox, also known as quantum superposition. Is this the end, or something far stranger? In this journey, we'll explore what happens when the weirdness of quantum mechanics collides with the raw power of a black hole. To understand this mind-bending scenario, we must first explore what actually happens as you fall into a black hole. Black holes are born from the collapse of massive stars, compressing extraordinary amounts of mass into a tiny region of space. Their gravitational pull is so strong that, beyond a certain boundary, the event horizon, nothing, not even light, can escape. As you drift closer, the force grows ever stronger, and time itself begins to slow down, at least from the perspective of a distant observer. For someone watching from far away, your descent would appear to slow and freeze as you approach the event horizon. In their eyes, you'd never quite cross that invisible boundary. But from your own perspective, you'd feel nothing particularly special as you pass the point of no return. You'd continue falling, accelerating toward the singularity at the heart of the black hole, where gravity becomes infinite and the known laws of physics break down completely. But long before you reach that singularity, you'd encounter the infamous process known as spaghettification. The gravitational difference between your feet and your head would stretch your body into a long, thin strand, as tidal forces rip you apart atom by atom. In classical physics, your fate is sealed. Destruction is inevitable, and there's no escape. But now, let's turn to the strange world of quantum mechanics, the realm of the very small, where particles don't behave like tiny billiard balls, but like fuzzy waves of possibility. One of the most bizarre phenomena in this world is quantum superposition. In this state, a particle doesn't simply exist in one place or another, but in a combination of all possible states at once. It's only when we observe or measure the particle that it chooses a single outcome, a process known as wave function collapse. If this is blowing your mind so far, hit that like button, subscribe for more wild science mysteries, and share this with someone who loves thinking beyond the edge of reality. Let's dive even deeper. To illustrate, consider Schrödinger's famous thought experiment, the cat in the box. Inside the box, the cat's fate is linked to a quantum event. Until the box is opened, the cat is both alive and dead, existing in a superposition of states. It's only when you look inside that reality chooses one outcome. So what happens if we apply this to a human falling into a black hole? Could you, like Schrödinger's cat, exist in a superposition of being both destroyed and surviving? And if so, what would that really mean? First, we need to grapple with the fundamental conflict between two of our best theories of nature: general relativity and quantum mechanics. General relativity, Einstein's great theory, describes gravity as the curvature of space-time itself, smooth, continuous, and deterministic. Quantum mechanics, on the other hand, deals in probabilities, uncertainty, and the strange dance of particles that can be in many places at once. Black holes, especially their mysterious interiors, force these two theories to confront each other head-on. At the singularity, the equations of general relativity break down, giving way to infinities and paradoxes. But what about the event horizon? What happens to information about you, your atoms, your memories as you fall in? Here, we encounter the black hole information paradox, one of the most perplexing puzzles in modern physics. According to quantum theory, information is never truly lost. But if you fall into a black hole and are torn apart, it seems that everything about you, the arrangement of your particles, the pattern of your thoughts, would disappear forever. Stephen Hawking famously argued that black holes might actually destroy information, violating the laws of quantum mechanics. But in recent decades, many physicists have come to believe that information is somehow preserved, perhaps encoded in the subtle quantum ripples at the event horizon, a concept known as black hole complementarity. Now, let's return to our thought experiment. You, the astronaut, falling into a black hole, but existing in a quantum superposition. In this scenario, your fate is not a single story, but a cloud of possibilities. In some branches of the quantum wave function, you might be torn apart by tidal forces. In others, perhaps you survive, at least for a short while, even as you cross the event horizon. In yet others, some unknown process might allow your information to escape, encoded in the Hawking radiation emitted by the black hole as it slowly evaporates over eons. Could you, in some sense, both survive and be destroyed simultaneously? In quantum mechanics, before observation, all possibilities coexist. The act of measuring, of observing, is what causes the universe to choose a single outcome. But who or what is the observer in the case of a black hole? If no one is watching, does your fate remain undecided, suspended in quantum limbo? Some physicists have argued that the event horizon itself acts as a kind of measurement device, causing the wave function to collapse. Others suggest that, from the perspective of an outside observer, you never quite fall in. Your information is smeared across the event horizon, forever out of reach. From your own perspective, you cross the horizon without noticing, only to meet your end at the singularity. But quantum mechanics allows for even stranger possibilities. In the many worlds interpretation, every possible outcome of a quantum event actually occurs, each in its own separate branch of reality. In one universe, you might survive for a brief time inside the black hole. In another, you're instantly annihilated. In countless others, subtle differences play out. From this perspective, the question, could a human survive falling into a black hole in a quantum superposition, has no single answer. In some branches, yes. In others, no. You both survive and don't survive, each outcome realized in a different, parallel world. But what does this mean for you, the conscious observer? Would you experience both fates at once, or only one? Here, the limits of our understanding become clear. Consciousness, quantum mechanics, and gravity are all deeply mysterious, and their intersection is a frontier where science meets philosophy. Some theorists have speculated that black holes might be the ultimate quantum experiment, a cosmic laboratory where the deepest mysteries of nature are put to the test. Could the fabric of reality itself be altered by the act of falling in? Would your quantum state, entangled with the rest of the universe, leave some trace, some echo, on the other side of the event horizon? Or would the very notion of you dissolve, replaced by a sprawling superposition of the possibilities? And then there's the question of information. If you're in a superposition, is your information truly lost or merely scrambled beyond recognition? Recent advances in quantum theory suggest that information might be preserved, holographically encoded on the surface of the black hole, a kind of cosmic ledger tracking every quantum interaction. If so, then in some sense, every possible version of you, every possible fate, is written into the fabric of space-time itself. Yet, despite these tantalizing possibilities, we must acknowledge the limits of our current knowledge. Black holes remain shrouded in mystery, their interiors forever hidden from direct observation. Quantum gravity, the theory that would unify general relativity and quantum mechanics, remains elusive. Until we can probe these realms, our thought experiments remain just that, glimpses into the deep, strange structure of reality. So, could a human survive falling into a black hole in a quantum superposition? In the realm of possibilities, the answer is both yes and no. Quantum mechanics allows for all outcomes, superimposed until measured. The ultimate fate of information, consciousness, and identity at the edge of a black hole may never be fully answerable. But what this question reveals is the profound strangeness at the heart of the universe, a place where certainty dissolves and reality itself becomes a tapestry woven from probabilities. Perhaps as you drift towards the event horizon, your fate splinters into countless threads, each one a story, a possibility, a universe of its own. In some, you are destroyed in an instant. In others, you linger, a ghostly echo encoded in the quantum ripples of space-time. In the end, the black hole is not just an object, but a question, a challenge to our deepest assumptions about existence, survival, and the nature of reality itself. So, could you survive and not survive at the same time? In the quantum universe, perhaps you already do.